So welcome back, guys. Let's start from the point where we stopped in the previous part of the same lecture. So let's move on to the next one. Plot the rolling 30-day averages against the close price for Encana and CNQ stocks for the year 2008. Hint is given: use pandas.dataframe.rolling, provides rolling window calculations. So this one is simply the info, cnq.info, and run this cell. He's not asking for this thing, he's actually asking for rolling 30-day average against the close price for Encana and CNQ in the year 2008. So he's asking for this plot. This is just one additional. So in this plot, instead of subplots, we can simply use plt.figure. Figure size is fixed size, set it to 12 and 6. You can set the figure size to any figure you want, and let's grab the Encana first. We can use the individual data frames Encana and CNQ here. Instead of our concatenated BO data frame, it's much easier to use simply Encana and grab the close column from the original data frame. So Encana and grab close. We can use IX to get a slice for 2008. So 2008, 01, 01 to 2008, 12 and 30. And then data frame dot rolling. So we call rolling here and pass in the window equal to 30. So when we are working with the rolling averages, and here the window is 30, we grab the 30 values and get the mean of those 30 values to plot on the chart. So what we did, we grabbed the close column for the year 2008 and calling rolling with window of 30 data points, and now we need to call mean on this window. So mean, and let's run this cell. And this is what we need to plot. Notice these NaN values. So because the window is 30, so we are getting NaN values in the beginning. So let's plot this data in the same line of code and call plot here and run this cell. And here we have the rolling averages of window equal to 30 for Encana. So we need to put the original data as well. Copy this line, paste it here. We need the original data, so we need to delete this rolling and mean methods. And let's rerun this cell. And here we have the original data, and the blue line is for rolling averages. The second one, we need to put the CNQ as well. So simply we can copy these two lines of code, paste them here. Instead of Encana, CNQ, and the rest of the code is going to be the same one, and rerun this cell. Here we have green and blue for the Encana's data and purple and red for the CNQ data. One thing is different, we need to put these labels as well. Should be very simple. Simply pass in label equal to Encana 30 day AVG. So let's split this code into two lines, and label equal to CNQ. Let's split this into two lines as well. CNQ 30 day AVG. And then we need to call plt dot legend as well, so that we get the legends on the plot. So once again, have a quick overview on this code. We are calling plt.figure and setting the figure size. Then we are grabbing Encana's close column, getting the slice for 2008, calling rolling with window equal to 30, and getting the mean for those data points. And in the same line of code, we are plotting on the canvas with label as in Cana 30-day averages. And then on the same canvas, we are putting the close price original data of Encana. The same canvas, we are putting CNQ rolling average for 30 window and the original data for the close price of CNQ. And let's rerun this cell. And here we have the same output. Once again, for rolling averages, we have some missing data in the beginning. This is because our window is equal to 30. So moving forward to the next question. So the next one is, a way to present correlations is to create a heat map. Please create a heat map of the correlation between the stock close prices. So we have multi-level indexed data frame BO. Let's grab the data. We need to grab close column for each entity at the index level, which is stock. So once again, we can use XS here. Our data for the heat map data underscore heat is going to be BO, and we can call XS. If we press shift tab, we have keys, axis, and level. Let's copy these three parameters and our key equal to close. We want axis along 1 because we want columns, and the level is stock. Let's check how the data underscore heat looks like. And here we have the date, entity RBC, CIBC, BMO, Suncor, Encana, and CNQ, and these are all the close prices. To get the heat map, we need to call correlation on our data. So we can call core here as well and rerun this cell. And here we have the data into the right format to get the heat map. So along the diagonal, we have the correlation of the entity to itself, whereas other values are like RBC to CIBC is 0.74, RBC to BMO is 0.084, and so on. So let's add a new cell below and call the heat map, and our data is data underscore heat SNS dot heat map, pass in data which is data underscore heat, and let's run this cell. And here we have our heat map. This complete code is in a single cell with a single line. So if you think you have enough understanding, you can simply write the code in the single cell as well. You don't need to display this correlation data in this cell. You simply need to recreate this heat map. So moving forward, he is asking for plot the interactive heat map. So this should be very simple again. If you remember, we can call iPlot and pass in kind equal to heat map. So our data frame, which is correlation data frame, is data underscore heat. So data underscore heat dot iPlot and pass in kind. Default is scatter. We can pass in kind equal to heat map. And let's run this cell. And here we have our heat map. So our color scale is different from the output that we need. So the color scale, what we need is RDY LBU. So this is not important. You can set any color scale. The most important thing is how to get this interactive heat map. Let's rerun this cell. So now we got the same color scale. If you move your cursor on this heat map, you get the correlation for RBC, CNQ, and the value of correlation, which is 0.44. And here you have BMO and Encana, and the correlation is 0.42. And these diagonals are the correlations of RBC to RBC, CIBC to CIBC, so the correlation of the company to itself. So moving forward, the next question is, let's see the cluster map. how the correlation make clusters together for stock close price. Once again, very simple. We have the data frame, which is data underscore heat. We can call SNS dot cluster map and pass in data, and then we need to set anode equal to true because we want values on the cluster map. Let's rerun this cell, and here we have the same cluster map. Moving forward, create a candle plot for Encana stock for 2008. So for the candle plot, we need open, high, low, and close prices. So we have the required data. Let's call the candle plot here. So Encana, and pass in the list of open, high, low, close. And we need the data for 2008. We can once again slice data using IX and pass in the dates 2008, 01, 01, and 2008, 12, 30, and simply call iplot and pass in kind equal to candle. Let's split this code into two lines, and here we have. So we are grabbing Encana's open, high, low, and close columns using IX to get the slice of the required data for 2008 and calling iplot passing kind equal to candle. Let's run this cell, and here we have the required candle plot. So the next one is technical analysis. Use .ta plot to create simple moving averages plot of Encana for the year 2015. Pass in periods 10, 30, and 50. If you want to learn more about TA_plot method, just follow this link and it will lead you to the documentation page. So let's create the plot. We can grab the close column from the Encana's original data frame instead of grabbing the concatenated one, which is multi-leveled indexed data frame. So Encana grab close, and then we can use IX to get the slice of the data. So we need 2015 data, 2015, 01, 01, and 2015, 12, 30. And then call TA_plot and pass in study equal to SMA and periods equal to 10, 30, and 50. And let's run this cell. And here we have the required plot. This is quite nice interactive plots with moving averages of 10, moving averages of 30, and moving averages of 50. So these lines are for 3 different moving averages, whereas the orange line is for the original dataset. So moving forward to the next question, there's another common type of data plotting, Bollinger Bands. Let's plot this one as well. So once again, we can use TA_plot method, and this is once again for Encana. So Encana, grab the close column. We can use IX again, and let's copy this code and paste it here just to save some typing, and .ta_plot pass in study, and in this case our study is ball, and run this cell. And here we have the Bollinger Band plot. You can explore this link and learn more about the Bollinger Bands. These are actually the statistical charts which characterize the price and volatility over the time of the financial instrument or commodity. So guys, this was all about the Capstone project. I hope you have learned a lot in this project. There was lots of finance involved in this project. You don't need to worry about understanding the finance because You are not supposed to learn finance in this course. The project was specially designed with lots of care to make you learn using real data. Yes, we can use lots of other data sets, but financial analysis is a very hot field nowadays. It is good to get some basics while doing data science, and this is the reason for creating this project on stock exchange. At the moment, the only thing you should be concerned with understanding are the basic pandas and data visualization. I suggest you guys to create a simple report using the above plots and write a page on your findings. See how the banking sector responded in the recession and how did they plan for the future. You can ask several questions to your data and find the answers, such as, do you think the oil sector learned from the recession and their future planning was good? Remember, while data analysis, reporting, and making suggestions, domain knowledge is very important. You must consider all the circumstances that played their role in the time period. So, guys, with this project, we are done with the data analysis and data visualization section. The next one is a very important and one of the important skill you need in the data science, which is machine learning. Let's move on and learn the most demanding skill in the market nowadays. See you in the next section. Good luck.